Don't forget to subscribe and press the bell icon to never miss a video from testbook.com.
So very good afternoon each and everybody. I am Dhiraj and I welcome you all in the Testbook.com, and I'm here to provide you the best I have. So guys, today we have bring what? We have bring for you that is Vizag MT, and it is a revision session for what? Mechanical engineering. We will try to revise the subjects right thoroughly. इसमें 2-3 subjects cover करूंगा, that I will try my best so that I will revise 3 to 4 subjects at least, right? At least, okay. So it's a what revision session. We are not going for question today itself, right? So before starting the session, what you have to do, you have to hit like, share and subscribe the channel, as well as my dear, what you have to do, you have to share the link of this video in your social media group so that the maximum people who are looking for the revision for Vizag MT, they will get benefited of it, right? Banerjee, Data, you are very good afternoon, very good afternoon. So guys, it's a revision session. I repeat, it's a revision session, okay? Today we are not going, it is a revision for mechanical engineering, right? And we are going to try to cover at least 2 subjects minimum, okay? So guys, yes, 3 people have already joined. So guys, we are going to start the session. Right now it's 2:59. We are going to start the session around 2-3. ठीक है? Within 3 minutes we'll start the session. 3 मिनट के अंदर चालू कर देंगे, okay? And whatever doubts you have, you can ask me. I have already uploaded what? PDF files for your study session as well. Okay. So we are going to start the session at 2:33. Very good afternoon to each and everybody. Yes, anybody have any queries, they can ask me. Guys, do hit like, share and subscribe the channel. If you are new to this channel, guys, do hit like, share and subscribe. Haji. Anybody have any doubts, then please let me know, those who are watching. Okay. And guys, I want to tell you one thing, that if you came to this channel first time, then I want to let you know that you can explore this Testbook Pass, which is single pass for multiple examination, and it is just right now we have mega sale offer in that you are getting it just for rupees 299. Okay, so you can explore the content of this pass, that is test in website as well as in the app. And my dear, we have already, that is guest fit, that is gate reward queues, and is what Get Festival 2021, and you have a chance to win the prizes, right? So you can also attempt it. You can also attempt it in the website, right? And my dear, we have already launched SSC JE Mechanical live coaching, right? It has been already started from 15th of November. You can get benefited of this coaching, right? And you can explore the demo classes, or we can say the preview classes of the SSC JE Mechanical, which are available in the website as well as in the app. So guys, you can explore. And if you are interested, or you supposed to be, if you have any kind of a doubt regarding, about any course, you can fill the form which is given in the description of this video. This video description में आप जाएंगे, you'll find the form. You'll find the form right here. Definitely for sure. Okay. PDF Kapil Singh ji, PDF is available. PDF is available. Yesterday's session जो है हुआ है, that is the session we have yesterday. The PDF is available in the comment section. You have to check out the comment section. I repeat, comment section check करना होगा. I hope you got it now. Okay. Please check the comment section of yesterday's session. You will get the PDF. जो वीडियो है, वीडियो के नीचे कमेंट सेक्शन होता है, उसमें आपको मिल जाएगा. Okay. So guys, it's now 3-2. Can we start? Can we start? चलें? Can we start? हाँ जी बच्चा. Those who are watching, please let me know. So my dear, here we go. Can we start now? Please put a thumbs up in the chat box. Kapil Singh. Okay. Okay. Here we go. Here we go. चलें? Here we go then. So today, my dear, today we are going to discuss about Today we are going to discuss about, my dear, I want to tell you that we are going to discuss about thermodynamic power plant, sorry, RAC then, and then my dear we'll go for power plant as well. तीन सब्जेक्ट के बारे में डिस्कशन करेंगे, तीनों सब्जेक्ट को रिवाइज करने की कोशिश करेंगे, एंड सपोज टू बी वी आर लेफ्ट विद सम टाइम, देन डेफिनेटली विल गो फॉर अदर सब्जेक्ट आल्सो. ठीक है, दूसरा सब्जेक्ट भी उठा लेंगे. ओके, हियर वी गो माय डियर. सो कैन वी स्टार्ट नाउ? So here we start, my dear. So first I will know what should be the format. Format will be, that is, I will cover the important stuff, other I will left. Okay? Important stuff I will cover, and I will left the part which is not important. Okay? Important in the sense I will cover each and every part in brief, not in depth. Okay? So here we go, because it's a revision session. Okay? So my dear, here we go for. So first of all, if you go for thermodynamic, we have what, my dear? We have systems. In that we have, my dear, open, we have close, we have isolated. Right? In that energy and mass are transfer. In that close only energy. Here nor energy, not mass, nothing. Right now? Yes or no? Okay. Okay. Very good afternoon. Abhit, very good afternoon. Right. And after this, my dear, we have seen what? We have seen, that is the universe. I'll tell you, universe is what, my dear? It is nothing but system plus surrounding. Surrounding is what? Surrounding is nothing but external to the system is what? Everything external to the system is what surrounding. And my dear, then we have seen property. Properties are nothing but what, bacha? Characteristics. These are what? Characteristics, and these are of two types. First one is what, my dear? Extensive, which is also known as what, my dear? Extrinsic. It is nothing but depend on extent of mass. Extent of mass पे depend करती है. Example क्या है बच्चा इसका? Volume हो गया. Then what we have? Volume. My dear, mass. My dear, enthalpy, entropy. These are what? These are nothing but what? Extensive property. My dear, second type of the property we have, that is what? Intensive. And it is also known as intensive. It is also known as what, my dear? Intrinsic. It is also known as intrinsic. You are most welcome. Intrinsic, that is intensive means what, my dear? Intrinsic. Yes or no? Intrinsic. Just know what you have to do. You have to just watch the video, and wherever you have doubt you can raise, right? And just watch, just try to listen only. ठीक है, ध्यान से देखना. Intensive. Intensive means what, my dear? Intrinsic property. Intrinsic means what? INT. INT means what? Independent. You have to replace the INT ka D, T by D. Independent of mass. And that will be what, my dear? And remember one thing. Here there is a note. Here there is a note that here you have to notice. That is, what should be the example? Let me write first example. इसके example क्या होंगे बच्चा? Density. Then, my dear, what? That is temperature. Temperature. Then what, my dear? What temperature is there? Okay. And there is one note over here. Write down one note, and that note is, my dear, all specific properties. All specific properties are what? Are intensive. Remember. Okay. I hope it's clear to you. Okay. Here we go. Here we go. No, there is no mock test. कोई mock test नहीं होगा आज. Here, that is what? Here we get off what, my dear? That is properties. My dear, you know that we have also known that is continuum. What continuum? Continuum. And you know that continuum is what? Continuum concept is nothing but what, my dear? Continuous distribution of mass. Right now? Right now, continuous distribution of mass. And it is valid. It is valid only when? It is valid. Continuum is what, my dear? Continuous distribution of mass without any blank space or void is known as continuum. And my dear, you know, MFP, that is mean free path, it is applicable. It is valid. It is valid only when this MFP MFP क्या होगा बच्चा? It is much lesser than system damage. Right. This you have to. And what is mean free path? Mean free path is nothing but a distance traveled by the molecules after two successive collisions. दो सक्सेसिव कोलिजन होने के बाद में जो डिस्टेंस ट्रैवल करेगा मॉलिक्यूल, दैट इज नन अदर देन व्हाट माय डियर? हाँ, दैट इज रिवीजन क्लास, टोटल रिवीजन क्लास. दैट विल बी व्हाट माय डियर? दैट इज नन अदर देन व्हाट माय डियर? सिस्टम डायमेंशन. Sorry, MFP. Okay, it is what, right? It is MFP. Then my dear, we have seen okay, then we have seen that is thermodynamic equilibrium. What? Thermodynamic equilibrium. Okay, what we have seen? Thermodynamic equilibrium. In that, my dear, what we have seen? We have seen three types. That is what? First one is thermal. Second one, mechanical. Third one, chemical. Fourth one, phase. Fifth one, electrostatic. Right? Electrostatic. हाँ, वो भी करा देंगे, डोंट वरी. ये भी करा देंगे सैम डेफिनेटली विल डू दैट, डोंट वरी. उसको भी करा देंगे. पहले ये फिनिश कर लें, उसके बाद वो भी करा देंगे, डोंट वरी. जब मैं बोल रहा हूं कराऊंगा तो डेफिनेटली आई विल डू इट. थर्मल. सो थर्मल मीन्स व्हाट माय डियर? इक्वालिटी ऑफ टेम्परेचर्स. Equality of temperatures. Mechanical means no unbalanced force. There is no unbalanced force within system. There is no unbalanced force within system. Chemical means what? Chemical reaction gradient potential. That means chemical reaction potential. Chemical reaction potential will absent, right? Phase means what? Mass of each phase remain same with respect to time. Electrostatic means what? There is a no unbalanced charge within the system. That we can say what electrostatic. If any system follow these 5 conditions, then we can say that system is what? In thermodynamic equilibrium. Okay, that system will be in thermodynamic equilibrium. I hope you got it. Yes or no? Very good. Now my dear, after this we have seen quasi-static process, that is quasi-static process, right? And it is nothing but what? That is a process, what process which happen infinitely slowly, or we can say very slow process. Very slow process. And most important point about this process, that means you can write, that is what? Every reverse, that is what, my dear? It is almost reversible. It is almost reversible, but not exactly. But not exactly. Right? I hope you got it. Here, it is. That means it is almost reversible. Which somebody say that is it is what? It is reversible exactly. No, it's not reversible exactly. Now, my dear, isentropic. Remember about this. That is quasi-static compression and expansion are considered as what? Reversible. One more point I want to add, that is another point, that is what, my dear? Reversible. Reversible क्या होता है बच्चा? That means the process reverse हो जाए. Process get reverse, keeping properties of system and surroundings same. Right? That is known as what? Reversible. One more point I want to tell you over here, that every reversible process, or we can say all reversible process or can be quasi-static. Can be quasi-static. Okay, can be, my dear, what? Quasi-static. But vice versa is not possible. हर quasi-static reversible नहीं होगी. Okay, here we go. Here we go. Listen to me very carefully. Now, my dear, now we are clear with what, my dear? Now, clear with this, and then, my dear, we have definition of what? Then we have, if I left something, then please remind me in the chat box. Pure substance. So, any system can be pure substance when it is single component system. Single component, and one another condition, that is chemical composition. Chemical composition same throughout. Right? Yes or no? Yes, of course. Okay. Okay. And after this, my dear, after this, we have, that is, we have what? Gibbs phase rule. बहुत जल्दी रिवाइज करेंगे, very fast, don't worry. Gibbs phase rule, and in that we have seen, my dear, that is what? P plus F is equal to C plus 2. And why here is 2? T is what? 2. यहाँ पे क्या है बेटा? ये 2 is what? 2 is nothing but what? N. N is what, my dear? Non-computational variable. And here we have only temperature and pressure, right? But in material science we have only one. That is what? Temperature only. Okay. I hope it's clear to you. Here we go. Now, my dear, listen to me. P plus F is equal to C plus 2. Right? Here F is what? Degree of freedom. Okay, degree of freedom. It is nothing but, we can say, what is degree of freedom? Minimum number of independent, or we can say intensive. Intensive variable लिखवा है. आप independent भी बोलेंगे, then you are also right. If you say independent, it is also right. Required to fix the state of system, to fix the state of system. Okay, here we go for next. It is all about Gibbs phase rule. Then, my dear, we come to the zeroth law. Right? And zeroth law said that, my dear, key supposed to be A is in thermal equilibrium with B. At the same time, A is also in thermal equilibrium with the C. Then these three can be in thermal equilibrium with another. That is, first TA is equal to TB is equal to TC. Right? And that is example is what, my dear? Example is what? Thermometer used by doctor. Thermometer used by doctor for what? For human body temperature measurement. Right now. And what are the conclusion of it? What is the conclusion? It provide what? It is basis for temperature measurement. It provide basis for temperature measurements right now. And once, that is, give the concept of what? Thermal equilibrium, not thermodynamic equilibrium. Huh? Thermal equilibrium and thermodynamic equilibrium, both are different things. Right? Then, my dear, it does not tell about, it's very important, huh? It's very important. It does not tell about the direction of heat transfer. Hi, Anna. Okay, here we go. These are very important conclusion, huh? जो भी मैंने ऑरेंज से लिखा है, इट इज वेरी इंपॉर्टेंट. बहुत कम जगह मिलेगा एंड इट इज कहीं ना कहीं एग्जाम में आया हुआ है. ओके, हियर वी गो, माय डियर. Then we have, my dear, what? Thermometers. What? Thermometers. Right. And in that, my dear, first we have seen which one? First, we have seen which one? That is what? Resistance, or we can say thermistor type of thermometer, right? Then we have seen, my dear, what? Then we have seen thermocouple. Then we have seen constant. What? Constant volume gas thermometer. Then, my dear, we have seen constant pressure gas thermometer. Right? Remember one thing. इसकी thermometry property is what? Thermometry property is resistance. It is having what, my dear? इसकी क्या होती है? हाँ जी, EMF. इसकी क्या होती है? प्रेशर. इसकी क्या होती है? That is what? Constant pressure gas. Constant pressure gas what? Volume. Okay. Bhima, you are most welcome in the session. Bhima, you are most welcome in the session. Here we go. Engineering club. Do you have any doubt? Please tell me. Till now कोई doubt नहीं आएगा. Doubt आना start होगा entropy से. Okay. Whatever the things I'm telling now, they will ask in the objective type of question. कुछ ना कुछ जरूर फंसेगा. Once again, listen to me very carefully. These two thermometer, constant volume gas and constant pressure gas, are known as what? Ideal gas thermometer. What बच्चा? Ideal gas thermometer. क्या बोला जाता है? Ideal gas thermometer. ठीक है? And remember one thing about the ideal gas thermometer, that is, it is independent of material of construction. Okay, it is independent of what, my dear? Material of construction. Okay, so this is all about what? Here we go. Now we have, my dear, temperature scale. So you know that before, मैं shortcuts में लिखूंगा, ठीक है? Before मतलब before 1954, we have two reference point scale. How many reference point of scale? Two reference point. And these reference point are, my dear, first one is boiling point, second one is what? Freezing point. Right? It is also known as what? Ice point. It is also known as what? Steaming point. Okay. Okay. Microscopic and macroscopic. Okay. Views हैं. I'll tell you. Don't worry. उसको ही बता दूंगा short में. 1954 we have two reference point scale. But after 1954, Kelvin established what? Kelvin established or Kelvin discovered single reference point scale. What? Single reference point. And the reference point he taken, that will be what, my dear? That is, let me take. Reference point is what? Triple point of water. What? Triple point of water. क्या था बच्चा? Triple point of water था. Okay. And one more thing. The triple point of water. What is temperature of it? 0.01 degrees centigrade. Right. Right now. And remember one thing about it. That is also given. That is 1 Kelvin is equal to 1 upon 273.16 part of Kelvin, sorry, triple point. Part of what, my dear? Triple point of water. Triple point of water. Okay. This is about Kelvin scale. And remember one thing. That Kelvin scale Is it what? Absolute temperature scale, or you can say, or my dear, thermodynamic scale. So that's why people say always put temperature in Kelvin. Kelvin, Kelvin. Why it is so? Because it is a thermodynamic temperature scale in thermodynamics. Okay, Kelvin scale ही है वो. Okay, I hope you got it. Yes or no, बच्चा? And remember thing, what is relationship between that scale when you are considering two reference points? So I'll draw. Supposed to be ये क्या है? Boiling point है दोनों का. Boiling point and it is freezing point. And it's supposed to be degree centigrade है. And it is what, my dear? Fahrenheit. Okay. So your boiling point कितना होता है यहाँ पे? How much it is? Yes, my dear friends. कितना होता है? It is none other than what? 100. It is 0. यहाँ पे कितना होता है बच्चा? ये 212 होता है. And ये कितना होता है? 32. You know that, right? And what is formula? Formula should be what, my dear? Can you tell me? It should be like this. That is Tc minus what? That is Ti. I means 0. Ti, I'll write in general. Ti divided by what it should be? It is what? Steaming point. That is Ts. This Ts minus Ti. Right? It is equal to Tf minus Ti divided by what, my dear? Ts minus Ti. ये दोनों का respective scales का. It is for Celsius scale and it is for Fahrenheit scale. You can put the value and you can convert the respective temperatures in any kind of scale, right? उस scale पे, if you want to find out any temperature in that particular thing, then what you have to do, you should know the boiling point temperature and freezing point temperature. Okay, I hope you got it. Here we go for next. One more thing that I want to tell you. Please take a note. That is what, my dear? That is what? Temperature scales are. Temperature scales are arbitrary in nature. What does it mean? I'll explain. What does it mean? I'll explain. Supposed to be, I have two thermometers. Okay, remember. Okay, it has supposed to be, इसमें क्या है? अल्कोहल है और इसमें है Hg, mercury. Supposed to be these two are calibrated at boiling point at this point. That is what? Boiling point. And here both of them has what, my dear? Freezing point. That is ice point. Okay. So, my dear, these two thermometers, these two different thermometer will show the same reading at what? Calibrated points. That is what you have done calibration for boiling point and freezing point. That is ice point, right? So it will show, both of them will show what? Same reading. Supposed to be अगर supposed to be यहाँ पे 100 दिखा रहा है, so definitely mercury भी 100 दिखाएगा. Supposed to be it is over here, यहाँ 0 है, तो ये भी 0 दिखाएगा. But whatever in between, what will happen in between? Because in between में कुछ तो readings होगी. So I want to tell you, it's not sure. यहाँ पे जो in between होगा reading, यहाँ पे हो सकता है ये 20 दिखा रहा हो सकता है ये दिखाएगा 30, right? 25, 18, like this. That means in between it is not going to same. It may be or may not be. हो भी सकता है same हो भी नहीं भी हो सकता कि same. It's not compulsory कि same होगा ही. Okay. I hope you got it, guys. Okay, here we go. Here we go for next. Then my dear, we come to what? Non-flow work. Then we have come to the non-flow work. That is what? Control mass, energy analysis, right? That is non-flow work. And that will be, my dear, क्या था ये? It is what? PDV, or we can say it's a boundary work. Yes or no? Yes or no? Yes, my dear. Yes or no, बच्चा बोलो. That means dW is equal to PdV, right? I hope you got it. Okay. But now we'll derive. ये हमने derivative देखा था, right now. Now we'll derive the what? Equation for first law, different processes में क्या होता है what? So first of all we'll go for constant volume. So constant volume में what will be the what? Volume is constant, so dV will equal to 0. So W क्या होगा? 0 होगा. हाँ या ना बच्चा बोलो. W is equal to what? W is equal to 0. Okay. Here we go. W is equal to 0 hoga. Then we have, my dear, what? Constant pressure. P equal to C process. In that, what will happen? W is equal to P into what? V2 minus V1. That is V2 minus V1 in third one. And that will be third one, what, my dear? T is equal to C. In that, we have derived different equation. That is what? It is, we got P1 V1 ln of what, bacha? V2 by V1. Or we get you can replace what? P1 V1 by what? MRT1 ln of V2 by V1. You can also write it like what? P1 V1 ln of P1 by P2. It is also correct. You can just change the values of P1 V1 V2 by V1. You can get different forms. I hope you got it. Here we go for next, and that is none other than what, my dear? When we go for that is PV raised to power n equal to C. That is polytropic process. In that we have find out. क्या मिला था बच्चा? We find out P1 V1 minus P2 V2 divided by what? N minus 1. And when it is what? Gamma. When it is what? Adiabatic. When it is adiabatic, it is what, bachcha? It is none other than you have to simply replace. Your W is equal to simply replace by, right? Okay, here we go for next. Here we go for next, my dear. See here. My dear, now I'll tell you about isothermal. So it's a very slow process. क्या होती है? Very slow process. It is what? It is very slow process. Okay. And one more thing. If compression or isothermal compression needs less work. Yes or no? Here we go. Okay. That you have to keep in mind. Okay. And one thing, it is very slow process. Okay. And remember, इसका जो slope होगा बच्चा, क्या होगा? Can you tell me the slope of it? dP by dV. What it should be? TV is equal to C ना? क्या होगा? TV is equal to C, तो इसका जो slope आएगा, that is dP by dV is equal to what, my dear? Minus P by V आता है. Okay, at constant pressure, temperature, right? And when we are talking about adiabatic, then it is very fast process. Right? It is very fast process. Okay. क्या होता है? Very fast process होता है. And in that, remember one thing. That is dP by dV. That is slope क्या होगा? T is adiabatic में ना, that is PV raised to power gamma is equal to C पे क्या होगा बच्चा? It is gamma P by V. Means gamma times ज़्यादा होता है. Okay. Here we go for next. Okay. Different. Okay. That means it is what? It is gamma times more. Now I'll go for that is what? Another thing, that is what? Remember one thing. Area enclosed, that you know. In PV diagram is what? PV diagram is what, my dear? Work done. And remember, area enclosed in TS is what? Heat. Heat supplied. Okay. I hope you got it. Yes or no? Okay. Now after this, my dear, you come to know about what ideal gas equation. What ideal gas, and you know that what PV is equal to nRT is also a equation of ideal gas. It is also a equation of ideal gas. And remember one thing over here, that is PV is equal to small v is equal to RT. It is also a equation of ideal gas. These are nothing but ideal gas equation, right? And here remember R is equal to bar R, that is what universal. It is what M, right? Okay, I hope you got it right now. Yes, okay, it's clear. Okay, here I go. अभी और आगे चलते हैं, right? And after this, my dear, after this what we have gone for, इसके बाद चलते हैं हम लोग, that is representation of various processes in PV diagram. ठीक है? So let's see. Representation of all the process. First we'll see for what, my dear? Expansion के लिए देखेंगे, for expansion and for compression. Okay, and it is what? PV. How it looks in PV diagram, that we are going to see, my dear. It may be asked in the exam for 1 mark. Okay, so and another question is also generated from it, don't worry. It is like this. It is, I'll draw, don't worry. Let me draw the first process, then I will let you know each and everything one by one. Right? So supposed to be, and we have general equation for the cycles, and that's supposed to be PV raised to power K is equal to constant. So for this process, K is equal to what, my dear? K is equal to 0. Are hai na? And this is what? This is isothermal. Then K is equal to what, my dear? K is equal to 1. Then again, this is what, my dear? Polytropic. So K is equal to what? N. This is what? Adiabatic. Adiabatic have very high steep. That is steep hoga na? That is it. Slope of the adiabatic is greater than from what? Isothermal we have already seen. So it should be what, my dear? K is equal to, that is K is equal to gamma. And it is what? Constant volume. So constant volume के लिए क्या होता है? K का value हो जाएगा, my dear, infinity. It is case of what? It is a case of expansion. Now I'll draw for the compression. Okay. So see. Okay. It will be like this right now. And remember, steep सबसे ज्यादा किसका? इसका. And it will be what? It is what? Constant volume. So definitely K is equal to what? In its compression, volume has been reduced. You can see from the process 1. Here it is the initial point. That is 1. Process has started from here. Volume has been reduced. So it is what, my dear? K is equal to gamma. This is equal to what? K is equal to N. K is equal to 1. And this will be equal to what? K is equal to what, my dear? 0. What? 0. And these are nothing but representation of the various process. Okay. Here we go for next, my dear. Just watch, nothing. Don't comment. Just watch it. Okay. Remember. And I'll go for another thing. And that is what? Let me check what. Now we have. We should know. You should know what, my dear? Specific heat. What? Specific heat. And it is none other than what, my dear? It is a amount of heat needed for unit mass of a substance to raise its temperature by 1 degree centigrade. Is known as what, my dear? Specific heat. And you know, if you do it at constant pressure, that will be Cp. And if you do it what at constant volume, that will be what? Cv. That is specific heat at constant volume and specific heat at constant pressure. My dear, remember Cp is greater than from Cv. Why it is so? I'll tell you. जो Cp होता है, in Cp there is internal energy and there is involvement of work. But here in Cv, as the constant is volume is constant, there is an involvement of only what? Internal energy. So that's why what? Cp is greater than from Cv. Always remember one thing. Okay. I hope it's clear to you. Now I'll go for my dear. Now I'll go for first law of thermodynamics. किसके लिए जाएंगे बच्चा? अभी जा रहे हैं फर्स्ट लॉ. TD. वेरी ब्रीफ मैनर में डिफाइन करेंगे. ठीक है. Remember one thing. Joule has done experiment and he had found for cycle. He had found that for cycle, he had found cyclic integration of what? Cyclic integration of dW is equal to cyclic integration of dQ. Right, means whatever the amount of work you are supplying, that will get converted into equivalent amount of heat for cycle. For process, what they have done? For process, they have said, my dear, they have said that is dQ is equal to what, my dear? Delta E plus delta W, and it is for reversible as well as for irreversible. दोनों process में applicable. It is applicable for both, whether it is a reversible process or whether it is an irreversible process. Okay. Okay. I hope you got it. Now after this, my dear, we go for what? We go for heat. Right. That is what? Heat transfer. Heat transfer. How to calculate heat transfer in different process as we have done for work. Right. So if I talk about, my dear, if I talk about what? First one. If I talk about constant volume, then what it should be? I have dQ is equal to what? dQ is equal to, my dear, I have, and it is for, I am talking about for closed system. Remember, for closed system. So dQ is equal to what it should be? That is for constant volume. You know that your U is what? Internal energy is what? 0. So we have equation that is, my dear, closed system has, so we have this one. So dQ is equal to what, my dear? PdV, because this U is equal to what? mCV dt. Sorry, it is constant volume now. Sorry, it's constant volume. So it will going to be 0. It is equal to du, and that will be equal to mCV dt. Right? If I go for constant temperature, then, my dear, it is dQ is equal to du plus PdV. It is what? It is none other than what? mCV dt. So dt is going to 0. So definitely it will also going to 0. That means dQ is equal to what? PdV. That is what? For isothermal. Right? And what is condition? This formula is applicable when, my dear, it is what? It is only closed system. It is applicable only that closed system. Closed system is a compulsory condition because here we have taken du, not de. Okay. Then, my dear, if we go for third one, and that is what? Constant. If I go for constant pressure, that is P is equal to C, then what it should be, बच्चा? किसके बराबर आती है? I got dQ is equal to, my dear, dH, enthalpy के बराबर. हम enthalpy के बराबर. From here, that H is equal to, my dear, what we get? H is equal to mCPT. mCPT. Remember, for ideal gas. Okay, number 4th. And here we also got, my dear, that is what? Cp minus Cv is equal to R. And we also got Cp is equal to what, my dear? Cp is equal to what? Gamma R upon gamma minus 1. And we know Cv is equal to R upon gamma minus 1. And you know that Cp by Cv is equal to gamma, and Cp is equal to gamma Cv. And you have Cv is what? R upon gamma minus 1. So you have to multiply gamma, you will get Cp. Yes, and Cp is greater than from what? Cv we have already studied. Haji bacha, is it clear? Now I'll go ahead. My dear, now I'll go ahead. I hope you got it here. Now in fourth one. Fourth one, what? Adiabatic. In adiabatic, you know that it is what? It remains constant. So definitely it should be what? 0. It is what? 0. Okay. Number fifth, my dear. What? Polytropic. What? Polytropic. I'll tell you in the polytropic, don't worry. So for polytropic process, what is Q poly, my dear? Q poly क्या था? It is none other than what, my dear? क्या था बच्चा? It is W poly, that is P1 V1 minus P2 V2 divided by N minus 1 multiplied by gamma minus N upon gamma minus 1. Right? And you know that this W poly is always P1 V1 minus P2 V2 upon N minus 1. Right? Right now, this is formula for calculating heat transfer in polytropic process. Okay. Okay. If you are talking about, I'll tell you, I will discuss in, what is your name? Let me check your name. Okay. Ayush, definitely I'll tell you whether, let me come on that topic. That is consequences of first law of thermodynamics. Okay. Consequences of first law of thermodynamics. Energy of system is what? Energy of system, my dear, always what? Point function. Point. What I said, energy of system. I repeat once again. I'll tell you on that, don't worry. Now we'll come to this one. Point fifth ho gaya. Now we have, my dear, what? C poly. C poly we can calculate, and it is none other than what, my dear? Q poly divided by what? M into dt. And you will get, my dear, it is none other than what? Minus CV gamma minus N upon, क्या होगा बच्चा? It is N minus 1. And it is negative. Why it is negative? Why it is negative? It's negative means what? Means what? Whatever the amount of heat you have supplied to this system, and whatever the work you have getted, that will be greater than from this Q. And whatever the extra work, this extra work came from what? At the cost of internal energy. And that's why internal energy has been dropped. Even though, that's why, even though you are adding heat, still the specific heat has been decreased. I hope you got it now. I hope you got it. Here we go for next. Here we go for next. Okay. Now, my dear, we'll discuss about consequences. Consequences of first law. Okay. Consequences of first law. इस पे बात करेंगे directly. That means first of all, that we have seen, that is Q is what? Path function. Heat is what? Path function. Then, my dear, energy of system. Energy of system, जिसको आप अगर system की energy, that is what? Internal energy. System के अंदर कोई भी energy होगी, that is what? Energy. That is what? Internal energy. So, my dear, I'll say internal energy of system is what? Is what, my dear? Is point function. Is point function. Number three is what, my dear? Can you tell me? That is क्या होगा बच्चा? Anybody of you? PMM1 possible है नहीं? PMM1 is possible or not? PMM1 is not possible. PMM1 is not possible. Okay. Second, और क्या होगा बच्चा? That is energy of isolated remains constant. Energy of isolated system. Energy of isolated system remains same. Remains constant. Okay. Here we go for next. Let me check. For real gases, internal energy depends on temperature only. No, temperature and volume. It's for ideal gas. U is function of temperature for ideal. U is function of temperature and volume for real. Here we go. Now, my dear, we'll apply the first law of thermodynamics for what? Open system. And we'll try to get steady flow energy equation. what we have seen steady flow energy equation, and that is what, my dear, that is none other than, we have find it already, that is h1 plus v1 square by 2 plus gz1 plus q is equal to h2 plus v2 square by 2 plus gz2 plus what, my dear, plus what, plus w. Remember one thing here when this, see what I mark, this h, this q, this h2 and this w, when these are in, my dear, joule per kg, then there is no issue that velocity will be in meter per second. But my dear, when this is in kilojoule, you have to divide it by 1000. Okay, I hope. And then, my dear, then we have seen what, my dear, for ideal gas, what, U is equal to what, mCV T, and H is equal to, my dear, we have already seen, that is mCPT, right? And once more thing that I want to tell you, we have applied this steady flow energy equation to turbine, to boiler, to nozzle, to diffuser, right? So if I apply it for what, nozzle, my dear, and you know that nozzle have initial velocity is quite very less as compared to the final velocity. So, my dear, we get the formula V2 directly. I'll directly write. Okay, what you get? You get 2 into H1 minus H2. And keep in mind that this V2 will be in meter per second only when this H1 minus H2 will be in what? Joule per kg. Supposed to be this is in kilojoule per kg, then you have to multiply it by 1000. Okay. Okay, remember. And when you apply for what? Diffuser. When you apply for diffuser, then what will happen, my dear? What will happen? In that, you know that in diffuser is what? Diverging section. In that, V2 is negligible as compared to V1. So, my dear, here we get V1. V1 will be what, my dear? 2 into H2 minus H1. Right? And you know that it is what? It is again, it should be in joule per kg. Then and only you are getting V1. That is in meter per second. Right? Yes or no? I hope you got it. Here we go. Chale. See, and if you go for turbine, my dear, what it should be? Turbine ke liye kya aata hai? That is, you got W. W is equal to what? H1 minus H2. If you go for compressor, my dear, what you will get? If you go for compressor, then what you will get? You will get W input, and that will be nothing but what, my dear? H2 minus H1. If you go for boiler, you will get, my dear, Q is equal to what? What it should be? Q kitna aega, bacha? It should be H2 minus H1. Right? I hope you got it. Haji, bacha. Yes or no? But you have to keep in mind that we have derived, when you got talking about compressor and turbine, we have assumption that what the assumption we have taken, that is steady flow, change in PE is equal to change in kinetic energy is equal to 0. And what else you get? What? That is what? It is, flow is what, my dear? Adiabatic. So definitely adiabatic hai, to kya hoga? Q is equal to 0. Right? In earlier case, that is in nozzle and diffuser, what should be the assumption? In nozzle and diffuser, क्या assumptions होंगे, my dear? Steady flow, change in, क्या होगा? Potential energy is 0. हाँ या ना? Yes. Adiabatic. And one more thing, क्या होगी और चीजें क्या होगी? That is W of control volume will be 0. Right? Right now, here we go. अब देखते हैं next point, and that is next point what we have to, throttling. We have also gone for throttling. Throttling पे भी गए हैं. So in the throttling, my dear, I'll to tell you, see. Throttling क्या है? It is isenthalpic process. In that H1 is equal to H2. Remember one thing, and pressure always decrease. Pressure क्या होता है? Drop होता है इसमें. And in that there are three cases. That is, in real gas there are two cases, and in the ideal gas there are one case. Sorry. When the throttling of real gas has been done, my dear, in that you will get what supposed to be ये अगर आपका throttle device supposed to be a throttle device है, it have temperature T1 over here, and it is what after throttling temperature T2. So एक case ऐसा आएगा that you will get T2 is greater than from T1. If it is so, you are getting heating effect by throttling. And there is another case, that is what you are getting, my dear, T1 is greater than from T2. That means it is what it is. It will lead to cooling effect, and it's also get clear by what Joule-Thomson coefficient, which we are going to see in pure substance. Don't worry. Okay. And you know that, my dear, H1 is equal to H2 for right. In ideal gas, you know that H1 is equal to H2, right? That means what? अगर H1 is equal to H2 है बच्चा, so what it should be? आपको पता होना चाहिए कि ideal gas में enthalpy is only a function of what? Temperature, because what we write, H is equal to mCpt, capital H is what? mCpt. mCp is constant, it depends on temperature only. So if I write, my dear, that is what? T1 is equal to T2, that means temperature remains constant. So always keep in mind, it is not 100, it is not, we can say that always, that if there is a drop in pressure in throttling, so definitely there is what? Decrease in temperature or increase in temperature remains constant. How it is? So that I have explained. Okay. My dear, then we have gone for unsteady state. In that you have to only keep in mind one formula. I'll tell you. Unsteady state. Because इसमें charging type के question पूछता है. There is a charging from a tank. There is a charging from pipeline of a tank, right? So this kind of a question has been asked. I will tell you what you have to remember. Okay. क्या याद रखना है, क्या नहीं रखना है, I will tell you. See, अभी तो जल्दी से 1 घंटा हो गया, पता नहीं चला. Okay, so my dear, you know that we got equation, that is what dE by dt will be what, my dear, of control volume is equal to what? It is mi in bracket, my dear, what? hi, that is hi plus cr square by 2 plus gz1 plus q, right? Minus क्या बच्चा? It is me bracket he plus ce square by 2 plus gze, okay, plus w, right? Yes or no? If you neglect the kinetic energy and potential energy, and you know that the internal energy of the system is made of what, my dear? Kinetic energy plus potential energy plus energy at molecular level, that is U, right now, plus any other form of energy. So if you neglect it, that is what? T is equal to 0 कर दोगे आप, so E will become is equal to U. So my dear, it is what? du by dt is equal to, see, it will become what? mi, right? ये दोनों गुजर जाएंगे because potential energy and that has been 0 plus q minus mehew, sorry, minus w. I hope you got it. Yes or no बच्चा? क्या हो जाएगा? Minus w, right? अरे सॉरी, यहाँ पे भी माइनस होगा. I'm very sorry, यहाँ माइनस होगा. Okay. So it is what? It is unsteady flow energy equation. What? Unsteady flow energy equation. That you have to keep in mind. ये ध्यान रखना. But now the question, exam point of view, which result is important? So I want to tell you, the numerical has been asked like this. That is, there is a pipeline and the tank has been charged. कुछ भी tanks में भर रहे हैं, right? Okay. कुछ भर रहे हो अगर ये वॉल लगा हो. Supposed to be इसका जो इंटरनल एनर्जी इनिशियली 1 है, ऐसा सब दे देगा, राइट? यहाँ पे मास m1 होगा, इट विल गेट कन्वर्टेड इनटू m2 एंड इनिशियल एंड फाइनल स्टेट में. सो यू हैव टू कीप इन माइंड, माय डियर, कि यहाँ पे जो फाइनल इंटरनल एनर्जी होगा, दैट फाइनल इंटरनल एनर्जी, दैट इज U2, इट इज इक्वल टू व्हाट? HI, जो पाइपलाइन में होगी, दैट इज व्हाट? इनिशियल एंथैल्पी. And if it is so, my dear, you will come to know that is T2 is equal to gamma times of initial temperature. Okay, that this result you have to keep in mind. This result you have to keep in mind. Okay, here we go for next. Chale aage. Here we go. Okay, so see, now we are going to talk about the second law. We are going to talk about the second law of thermodynamics. Second law. So why there is necessity? So there are some limitations of first law. First law के क्या क्या limitations थे? That first law does not provide. First law limitations. Due to the limitations of first law, there are a lot of limitations in first law and zeroth law. There is a need of what? Second law, and that second law will be what, my dear? I'll tell you. That is what is limitations. So limitations क्या था? That is it does not tell about first law. Remember, I'll write first law limitations. Okay, and that are what, my dear? First one. That is what? First law limitations. Remember, that is first law limitations. First one is what? It does not tell about. Does not tell about what? Feasibility of process. Feasibility. Second, feasibility of what? Feasibility of process or cycle. And my dear, what extra? It does not tell about direction of energy transfer. Direction of energy transfer, right? It also does not tell about, it does not consider, or we can say it does not tell about degree of irreversibility. That means quality. So that's why it does not talk about quality, right? So I'll say the first law is what, my dear? First law is all about first law. That's why this first law is known as quantitative. आप एग्जाम में पूछा जा सकता है, बहुत सारे एग्जाम में पूछा है. Second law is what, my dear? Second law is what? Qualitative law. Okay. So second law had two statements. The first one is what, my dear? Kelvin-Planck statement. And Kelvin-Planck statement, what it said, my dear? इसने क्या बोला? He said that it is not possible to convert. It is not possible for any cyclic device which can convert or which can produce an equivalent amount of work by exchanging energy with a single thermal reservoir. That means इस लॉ को मैं डायग्रामेटिकली ड्रॉ करके बताता हूं. Okay, I will draw it diagrammatically. Supposed to be T1. यहाँ heat supply है QS. It is W, and it is any kind of device, right? So he said it is not possible. Because this W is equal to what, my dear? W is equal to QS हो जाएगा. That means what? It is not possible. It is not possible. And if it is so, my dear, if it is so, it is what? It is PMM2. It is what, my dear? It is PMM2. And I want to tell you, if such kind of device supposed to be exist, that it have what, dear? Efficiency will be what? 100%. But Kelvin-Planck state that 100% efficiency is not possible. 100% efficiency is not possible. That has been said by the Kelvin-Planck statement. Remember. And it talks about what? It talks about what? Heat engine. Talks about heat engine which converts what? Heat into work. And this question has been asked in, you know that, in UPPSC 2013. क्योंकि जो previous year paper है उसमें question आया हुआ है as it is. Okay. Here we go for next. Then, my dear, that is Kelvin-Planck statement. We have this kind of thing, right? And it also gives the birth to what? Heat engine. So you should know कि heat engine क्या होता है. So heat engine बच्चा simple सी चीज है. It is none other than what? This, that is T1 से लेता है. Here we have Q heat supplied, that is what? Q rejected, and it is what? W, and W is equal to QS minus QR होता है. Right now? And you know efficiency formula we have of heat engine. That is not That is what, my dear? That will be what, my dear? 1 minus TL upon TH. Where is TL? Here it is TL. And remember, this TL and TH is in what? In Kelvin. किसमें होने चाहिए? Kelvin में. But I want to tell you this formula is applicable for reversible engine. Only reversible engine के लिए formula applicable है. Okay. But supposed to be. And we have another formula for this. That is what, my dear? 1 minus QR by QS. And this is applicable for reversible engine as well. It is also applicable for irreversible engine. But you have to keep in mind that this is only possible when the engine is what? Reversible. So keep in mind. My dear, then we have another statement. Then we have another statement that is of second law. That is what? Clausius. That is what? Clausius. Okay. So what Clausius said? Clausius said that it is not possible. That means the heat can, or he said, supposed to be, I'll draw. That is Q1, it is Q2, it is what? TH, it is what? TL, right? And it is supposed to be heat, any kind of device, not heat pump, I'll say. Any kind of device, right? But here you can see, it is not possible. What this device done? See, this device is taking the heat from low temperature and delivering it what? At high temperature without having any input. So Clausius statement said that it is not possible for any single kind of any single device or any cyclic device, those who can transfer a heat from low temperature to the higher temperature without aid and an external agency. It is not possible, right? That means what? According to the Clausius statement, it is wrong. It is wrong, right? So that means what he says, and supposed to be, if such kind of device is there, then my dear, it have what? COP will be what, my dear? 100. Yes or no? Or we can say infinite. Infinite. Yes or no? Because infinite aega. Why it is so? Because COP of heat pump will be what, my dear? That is heat you have rejected. That is what? Q1. And work is what? 0. So anything by 0 will be what? Infinity. Right? So one thing. And remember one thing, that Clausius, that means if you want to transfer, I will draw the correct diagram. See. So you have to give some heat, that is, sorry, work. It is what? Heat pump. It is what? TH. It is what, my dear? TL. It has taken heat Q1. It is what? Q2. So it is heat pump. So what is COP? COP will be, my dear, that is what? 1 minus, sorry, it should be what? TH upon TH minus TL. It is only for what? Reversible heat pump. And supposed to be, you have formula, that is what? Q2 divided by what, my dear? Q2 minus Q1. This will be what? This will be what, my dear? This will be none other than, my dear, kya? It is applicable for reversible as well as for irreversible. Okay? I hope it's clear to you. Here we go. Here we go for next. That means the funda of heat pump is also clear. And supposed to be, I'm going to talk about refrigerator. We have already done with heat engine, refrigerator, right? Heat engine and heat pump. So my dear, supposed to be, you have this device, right? What will be the refrigerator? I will tell you. So my dear, it is what? T higher, T lower. And it is what? Refrigerator. Say what it does. I'll tell you. See, Q1, Q2. What it does? It is none other than what? It takes a heat, or it will extract a heat from a conditioned space. Means where you have to maintain the low temperature as compared to the surrounding. So it will become what? Your refrigeration effect, right? And it will reject that heat into the atmosphere. As we have seen in the refrigerator, kya hota hai bacha? We have low temperature. So its COP will be what, my dear? Its COP will be what? TL upon TH minus TL. But it is for what, my dear? It is just for, किसके लिए होगा ये? It is for reversible again. And my dear, COP is equal to what? That is refrigeration effect divided by Q2 minus Q1. It is applicable for reversible and also it is applicable for irreversible, right? And one more thing I want to tell you, that COP of heat pump is equal to 1 plus COP of refrigerator is equal to 1 upon efficiency of heat engine. This is the relationship between them. And you have to keep in mind, इसको ध्यान रखना है. You have to keep in mind. Okay. Okay. Remember one thing. Here we go for next. This is all about what, my dear? This is all about the, now we are going to talk about Carnot cycle. What, my dear? Carnot cycle के बारे में बात करेंगे. So first of all, I want to tell you, it has maximum efficiency. It has maximum efficiency, not 100%. 100% नहीं होती, not 100%. It have maximum efficiency, okay? And it, why it is not possible? It have what, my dear? It have two isothermal process and two what, reversible adiabatic, or I can say isentropic process. Reversible adiabatic will be fast process. These are fast. These are slow. So combination of slow and fast is not possible. So that's why this cycle has been not possible. But remember one thing. What? Efficiency of Carnot is function of temperature limits. Right? Supposed to be, I have number of engines. So engine supposed to be. कोई बहुत सारे engine है मेरे पास. So all reversible engine will have what, my dear? All reversible engine will have same efficiency, provided that same efficiency when operating between same temperature limit. Between same temperature limit, that you have to keep in mind, my dear. I know handwriting थोड़ा सा वो हो रहा है, but it's a revision, my dear. And remember one thing, eta of reversible is always greater than from eta of irreversible. Okay, I hope it's clear to you. Here we go for next then. We have done what, my dear? We have done for that Carnot cycle as well. Now we'll go for Clausius inequality. What, my dear? Clausius inequality. Clausius inequality. Right. In that what we have seen, I will tell you. Clausius inequality में क्या होता है? That is what, my dear? Cyclic integration of what? dq by t is less than or equal to 0. And you know equality sign. That is what? Cyclic integration dq by t or dq by t, you can say, is equal to 0. For what? For reversible. Cyclic integration del q by t is less than 0. It is for irreversible. And somebody say dicyclic integration del q by t is greater than 0. It is impossible. It is not possible. Okay, that you have to keep in mind. Okay, I hope you got it. And remember one thing, that is, this is all about what? Clausius inequality. Based on this, we have defined entropy. Don't worry, my dear. I want to tell you that we have also, that is what, second law of efficiency. Yes or no? Second law of efficiency we have. In the second law of efficiency, my dear, we have derived, that is eta second. Eta second, what, my dear? It is nothing but what? W actual, W maximum, and W maximum will be more, right now. And what, my dear? What about the COP? Eta 2, that is COP. COP के बारे में क्या बात करेंगे? That is what? It is none other than 1 W minimum upon W what? W actual. Sorry. Remember one thing. It is for power producing cycle. It is for power producing cycle. And it is for what, my dear? Power absorbing. It is power absorbing devices. That is like a refrigerator, heat pump, compressor, like this. I hope you got it. Yes or no? Here we go for next, my dear. Here I go for next. See. Now supposed to be, I have two engine connected in series. Two engine are connected in series. Then their efficiency. Then then eta equivalent is equal to, my dear, that is one formula we have very common, eta 1 plus eta 2 minus eta 1 into eta 2. बट सपोज टू बी अगर वो n नंबर ऑफ इंजन दे दे सीरीज में, n नंबर ऑफ इंजन दे दे तो अगर n नंबर ऑफ इंजन दे दे, n इंजन कनेक्टेड इन सीरीज, देन so I'll suggest what you have to do. See my dear, क्या करेंगे आप at that time, eta equivalent 2 का भी आया, you can also get it, that is 1 minus eta 1, 1 minus eta 2, 1 minus eta 3 dash 1 minus eta n, जितने नंबर ऑफ इंजन हो गए, that is 1 minus को 1 से माइनस कर देना, that is product of what, all the efficiencies, but you have to subtract it from 1, right? 1 minus eta 1, 1 minus eta 2, second, third, fourth, fifth, sixth, whatever the n number of engine you have, right? And remember one thing also, that is a condition. यहाँ पे इसी दो इंजन के बारे में बता रहा हूँ. For same work, if you want same work from both the engines, here you have connected two engines, na? So for this I am telling, if you want for same work, then my dear, I want to tell you, that is intermediate temperature will be what, my dear? It is none other than T1 plus T3 divided by 2. Okay. And one more thing, that is if you want, that is same efficiency, or we can say eta 1 is equal to eta 2 चाहिए आपको, then what it should be? T2 is equal to under root of T1 into T3. I hope you got it. Yes or no, बच्चा? Here we go. चलें आगे. Wait, huh? Okay, here we go. That is T1 into T3. Now we'll going for, my dear, entropy. Right? So first of all, I will define entropy. So you know that it is what? This is nothing but dq by t. What, बच्चा? Del q by t बोल दीजिए, dq by t बोल दीजिए, and it is what, my dear? dq by t, that is for reversible, is known as what, my dear? ds, right? And it will be what? This will be known as what, my dear? It is what? Point function. ये क्या होगी? For reversible. And remember one thing, entropy is a point function for an only what? Reversible process. I repeat once again. Okay. And my dear, it is for reversible. And if I want to calculate for irreversible, my dear, then I want to tell you, it is what? ds for irreversible. It is, my dear, del q by t plus entropy generated, and this entropy generation is what, my dear? Path function, due to which the irreversible, that is entropy generation, entropy for irreversible process becomes what, my dear? Path function. It is not point function. Okay, here we go for next. It is what? Path function, right? T2 is equal to T1 into T3 ds, that we have done, dq plus as generated path function, सब बता दिया. Now listen to me very carefully. About this eta generation, I want to tell you कि ये क्या होगी. अगर ये 0 है, suppose to be eta generated is 0, that means it is which process? Reversible. If eta generation is greater than 0, it is what? Irreversible engine. Sorry, it is greater than 0, not 1. Huh? I'm very sorry. It is what, my dear? It is irreversible. Suppose to be somebody say eta generator is less than 0. It is impossible. It is not possible. It is impossible. So remember one thing. Now if I talk about isolated system. So isolated system में what we have, that is formula ds is equal to, my dear, del q by t plus eta generated. So there is because it's what? Isolated system, so there is no energy interaction, so it is what? Going to 0. That means ds is equal to, as eta generation means whatever the amount of heat, entropy, the amount of entropy going to be generated while the process, that is nothing but what, my dear? That is nothing but what? It depends directly on entropy generation, right? बट सपोज टू बी अगर सिस्टम आइसोलेटेड सिस्टम अगर रिवर्सिबल प्रोसेस में गया, so reversible process में there is what, there is no entropy generation will become zero, that means ds becomes zero, right? That means there is no change in entropy for isolated system when it is undergo what, a reversible process. But my dear, when it go for irreversible process, then this eta generation, that is entropy generation, will not be equal to zero. That has been clear. So can I say isolated system का जो entropy है, isolated system entropy will what, will remain same or increase, will remain same, sorry, or what, or increase, but never decrease. And this sentence is known as what, my dear? Entropy principle. इसी को क्या बोलते हैं बच्चा? एंट्रोपी प्रिंसिपल. बस सुनते चलो, बोलना कुछ नहीं है. Whenever you have doubt, you have to just put it कि हाँ सर आप डाउट है इसमें बता दो, ठीक है? Okay. I hope you got it. Now my dear, listen to me. If you want, suppose to be ये इंजन है, ये इंजन है, ठीक है? Okay, here it is what, head engine है, and it is simple heat engine. I not say कि reversible है कि irreversible है. W यहाँ दे रहा है. It is what Q. It is what Q, right? यहाँ temperature supposed to be 100 है. Here the temperature is 50. ठीक है? ठीक है? And here the Q has been 200, right? And supposed to be here the Q is supposed to be, my dear, 100. So if somebody asks you, okay, this engine is what, my dear? Whether this engine is reversible or irreversible, what you can say? आपका इंजन रिवर्सिबल है या इरिवर्सिबल है, हाउ यू कैन आइडेंटिफाई? सो माय डियर, आई वांट टू टेल यू, सी सीधा सीधा लॉ लगाना, Q by T करोगे, यहाँ पे क्या आएगा? 200 by 100. दैट मीन्स 2 by 100 by 100 मतलब एंट्रोपी यहाँ पे कितना है? 2. Here we have engine how much? That is 100 by 50. This means what? Again 2. That means the entropy is initially 2 and finally 2. That means there is no entropy generation within system. There is no entropy generation within system. I can say it's a reversible engine. Entropy generation 0 था ना? Yes or no? I hope you got it. Here we go for next. Here we, in this way you can identify. And my dear, supposed to be ये 150 होता, ये टेम्परेचर कुछ और होता, 150 होता है, 150 होता है, एंड ये कितना आ जाता? 3. ये कितना आ जाता? 3 आ जाता. So that means initially कितना था? 2, अब हो गया 3. That means entropy has been increased by 1. So it is what? Irreversible. Because entropy is not equal to going to be 0 in the second case. But supposed to be. Now there is another case. Some people say कि नहीं यार, now we have 50 over here and यहाँ से यहाँ पे 150 ना होकर सपोज टू बी यहाँ पे सिर्फ 25. तो माय डियर 25 by 50 इट इज व्हाट? 1 by 2. इनिशियली कितना था? 2. अभी कितना हो गया? 0.5. इट इज नॉट पॉसिबल. नॉट पॉसिबल. ओके, दिस इज नॉट पॉसिबल इंजन. आई होप यू गॉट इट. यस, मनी मारना. वेरी गुड. हियर वी गो फॉर नेक्स्ट. गाइस डू हिट लाइक, शेयर, सब्सक्राइब. आगे चलते हैं. ओके, and remember one thing, I will do some conclusion over here. Okay, and remember one thing, this is, I already explained, this is not property. It is not property. I already told you. This is not a property. I already told you. And remember, for cyclic device, if there is a cyclic device, my dear, so remember always, if any in the numerical dimension cyclic device, you have to say that is ds is equal to 0. That is dq by t. Right? And it is applicable for both reversible as well as for irreversible. What they have to mention, what, my dear? Cyclic device. Remember, because cyclic device में definitely initial and final point will be same. So definitely the change will be 0. Right? Right now, I'll tell you the things now. Okay. After this, we'll go for entropy analysis in the next page. From the next page, we are going to begin entropy analysis. It is what? Entropy analysis. Okay. सुनते रहो, just listen to me very carefully, don't comment or anything, just listen. Entropy analysis now we have to do. So my dear, if it is reversible, supposed to be I took reversible case, okay, reversible मान रहा हूँ process में, okay, so supposed to be entropy generation इसमें क्या होता है 0, and remember one thing, supposed to be I have taken one process, that is what, heat addition. What? Heat addition. Heat addition में, then what my dear, ds will be what, dq by t plus entropy generation, it is 0, so that means ds will be what, positive. And supposed to be it is heat rejection, then ds will be what, dq by t plus entropy generation, that will be what my dear, ये तो 0 हो जाएगा, dq by t will be what, negative. Why negative? Heat rejection we always took about my dear, negative, right, as per our sign convention. Am I right now? Yes or no? Here we go for adiabatic, then my dear, ds is equal to dq by t plus entropy generation, it is what, 0, as it is reversible. Adiabatic में change in heat will be 0, so that means ds is equal to 0. I can say it's what my dear, isentropic. So yes or no, every reversible adiabatic process, remember what I do, that is every reversible adiabatic, is what my dear, isentropic. But vice versa is not possible. How? I'll tell you. Okay, here we go. Now my dear, see, supposed to be I have taken the same case for irreversible. In that what happened, Sgen will not be equal to 0. Yes, okay, it will not be equal to 0. So what is that, is ds is equal to what my dear, dq by t plus entropy generation. So it is that at first I am talking for I am taking for heat addition. I am taking for what my dear, I am taking for heat addition. At first I am taking for heat addition, and that is ds is equal to dq by t plus what, entropy generation, right? That means what, heat addition ले रहा हूँ, so it is what, it is not equal to 0. So and it is heat addition, so obviously बात है, ये positive रहेगा, ये positive रहेगा, overall क्या रहेगा, positive आएगी. Change in entropy will be positive. But supposed to be it is a case of heat rejection, my dear, ds is equal to dq by t plus entropy generation. It is always positive. You know that it is always positive and it never decreases. So it is now negative. So हो सकता है negative positive neutralize 0 हो जाए. They may be isentropic. So it may be that, it may be what? It may be 0, it may be positive, it may be negative. Because हो सकता है the magnitude of dq by t will be higher. You don't know na. Right? So see here. Again, ds is 0. Supposed to be if we get ds is equal to 0, in this case, it become what? Isentropic. So that's why I said every isentropic process is not reversible adiabatic, because here we have taken what my dear? Irreversible adiabatic. Now third thing. Supposed to be it is adiabatic, irreversible. Then my dear, again you know that is ds is equal to dq by t plus entropy generation. It will not be my dear what? It will not be 0 and it will be 0 and it is always positive. So ds is equal to always positive. Right? I hope you got it. So that's why if any irreversible process wants to be in a isentropic process, then it should be non-adiabatic. It should be non-adiabatic. Because people have perception that adiabatic hoga, then definitely it should be isentropic. It is wrong perception. It is wrong perception. Okay. Here we go. 38, 7 done, 8 target. Okay. Now listen to me very carefully. Now we have first law of thermodynamics. Okay, we have done it. Now we'll talk about the combined equation of first and second law. That is none other than what, my dear? First law and second law का combined equation क्या है? TDS is equal to TDS is equal to du plus PdV. Wait. Du plus PdV, first equation. Second equation is what there, my dear? TDS is equal to dH minus VdP. Remember one thing, okay? And I want to tell you, what about the slope? Slope of dt by ds of what, my dear? At constant volume, V is equal to C. It should be, my dear, T by CV. And slope on the, that is TS diagram, that is TS plot pay, for of what? Constant pressure is equal to, my dear, T by Cp. What? T by Cp. Now you have to tell me, which one is greater. So you said that is dt by ds at constant volume. What? At constant volume. And dt by ds at constant pressure. Which one will be greater, my dear? Please tell me. See, Cp is greater. Cp is greater than from Cv, you know that. Right? So definitely if it is greater, the value of this constant pressure will be low. Yes or no? Yes or no? So definitely the slope of constant volume process will be higher than of constant pressure that you have get it. Okay? You can get it by this help of these equations. Okay? And these equations are applicable for reversible as well as and irreversible. दोनों का applicable है. But while deriving this equation, we have taken assumption what? Reversible process, right? But even we have taken what? Assumption of reversible process, it is still applicable for reversible as well as for irreversible process. Okay, here we go for next. Right, now my dear, we are going to do, that is what? That is, remember one thing here, I show you the figure of this. I'll show you the figure as well. Supposed to be, my dear. Supposed to be. Oh, sorry. ऐसा ले लो. Okay. इसमें से कौन सा प्रोसेस होगा? कांस्टेंट वॉल्यूम का, ऑब्वियस सी बात है, ये वाला. Why the slope is higher, right now? Right? I hope you got it. अगर मैं ऐसा बनाता हूं, ऐसा, इसमें से कौन सा होगा? ये वाला कांस्टेंट वॉल्यूम, V equal to C. Right now? I hope you got it. So my dear, now we'll go for entropy calculations. Wait. Let me choose the new slide. Okay. So now we are going for what? Entropy calculations. Entropy for different systems. Okay. Here we go, my dear. Just listen to me very carefully. Don't do anything. Don't comment. Just pay your attention on the screen. See, if it is a single thermal reservoir, if it is thermal energy reservoir, single and at a single temperature. So what it should be? ds will be, my dear, what? It have infinite amount of heat and it at single temperature. That is what? Q by T. Right? But when it is, when supposed to be, I talk about solid or liquid. Solid or liquid of finite mass. इनका क्या है? Mass finite है. Of finite mass. Second, of finite mass. First one we have taken. What it should be, my dear? It is none other than delta S is equal to MC ln of T2 by T1. Right now? Right? And one more thing. Supposed to be it is real gas. If it is real gas, then you have to follow, my dear, what? We have to follow TD relations. Right? I'll show you the TD relation, don't worry. My dear, if I talk about ideal gas, then it have different formulas. If it is supposed to be, it is ideal gas, third point. If it is ideal gas, my dear, then what we have the formula? So see, my dear, delta S, the first formula, we have what, my dear? MCP, that you can say Cp ln of T2 by T1 minus R ln of P2 by P1. We have delta S is equal to Cv ln of, my dear, T2 by T1 what? Plus RLN of V2 by V1. There is another formula. I hope किसी के पास नहीं होगा. That is what, my dear, I have added it from the examination. Exams पे पूछा गया था. So I have added it over here, and it is none other than what? CV ln of P2 by P1 plus CP ln of V2 by V1. This three formula you have to keep in mind. Maybe they will ask in the objective type question directly. Directly आ सकता है. Okay. I hope it's clear to you. Yes or no? Okay. And remember one thing. Now here we go. Supposed to be, we do mixing of incompressible fluids. Mixing of incompressible fluids. Then what will happen? What their that temperature and what their entropy change. So I'll tell you. Their final temperature supposed to be, we have two liquid fluid, that is T1, T2. T1 and T2. So what is final temperature? Their final temperature will be what, my dear? T1 plus T2 by 2. It is only when that is M1 is equal to M2. They have condition, and my dear, what? And C1 is equal to C2. Otherwise, if it is not equal, then TF will be what, my dear? M1 C1 T1 plus M2 C2 T2 divided by what? MC1 plus MC1 plus MC2, right? I hope you got it. M1, sorry, यहाँ पे M2 हो जाएगा, M1 C1. It is when M1 is not equal to M2 and C1 is not equal to C2. Remember, okay? This is what? This is all about final temperature, right? Now, my dear, what it should be? Delta S of universe. Delta S of universe क्या होगा बच्चा? It should be M1 C1 ln of T2 by T1, or we can say, sorry, TF. I'm very sorry, it's not T2. T2 means final hoga, but it should be TF you have calculated plus M2 C2 ln of TF by, sorry, T2 by TF, right? It should be TF by T2. Again, इसके लिए भी वही होगा, right? Now listen me very carefully. This is applicable when M1 is not equal to M2 and C1 is not equal to C2. But supposed to be when M1 is equal to M2 हो जाए and C1 is equal to C2 is there, then my dear, delta S of universe in general, what, my dear? It becomes twice MC ln of what, my dear? It is none other than arithmetic mean divided by geometric mean of temperatures. This arithmetic mean of what? Temperature, geometric mean of temperature. So in general, supposed to be there are, I have mixed two fluids, right? Supposed to be I have n number of fluids mixed. Then it should be, my dear, in general, NMC ln of arithmetic mean divided by geometric mean. It is when this happens, M1 is equal to M2. At that time, you can apply this formula. And one thing I want to tell you, arithmetic means width. Supposed to be you have two component, so it will be 2n plus T2 by 2. Geometric means what? Under root of T1 into T2. Supposed to be I have n number, so it's 3 है, तो then what it should be? You know that T1 plus T2 plus T3 by 3 हो जाएगा. ये क्या हो जाएगा? क्यूब T1 T2 T3 मल्टीप्लाई में रेस्ट टू पावर 1 by 3. 4 होंगे रेस्ट टू पावर 1 by 4. 5 होंगे रेस्ट टू पावर 1 by 4. And here addition T1 plus T2 T3 T4 plus T5 divided by 5 हो जाएगा. I hope you got it. Yes or no? Here we go for next. Okay, here we go for next, my dear. Okay. Now we'll go for what? That is, we have done, and now we'll go for maximum work obtainable condition. Entropy in case of maximum work obtainable when two finite bodies, जब दो block between two bodies which are what, my dear? which are allowed to exchange heat. Okay, so I want to tell you, यहाँ पे TF क्या होगा बच्चा? अंडर रूट, that is geometric mean होगा. And what will be the delta S? Delta S will be same. It is cyclic. So you have, your answer will be what, my dear? Delta S is equal to what, my dear? M1 C1 ln of TF by T1, right? Plus what, my dear? M2 C2 ln of TF by T2 is equal to 0 because it's a cyclic device. Okay, I hope you got it. And here you will get W. What will be the formula for W? W max, my dear. In general, what do you get? You get, my dear, when this, and supposed to be, remember, wait, I'll repeat, that is, when, in the next page I will continue, when the blocks having mass M1 is equal to M2 is equal to M, and specific heat is equal to C1 is equal to C, C1 is equal to C2 is equal to C, then at that time, my dear, we have W max will be what, my dear? It is none other than what? Twice MC divided by what? Arithmetic mean minus, sorry, not divided by, multiplied by arithmetic mean minus geometric mean. Supposed to be, I have n number of body between which are allowed to exchange energy. N number of bodies are there. So it should be NMC. My dear, arithmetic mean minus geometric mean. It is when these conditions are given. Remember, huh? Don't forget about these conditions. Okay. Here. I hope you got it. Here we go for next. My dear, now if I go for that is open system. So open system का work done क्या होगा? That will be none other than VDP. We have already derived. And kabhi there is a question that in which one is the process in which PDV is equal to VDP minus VDP. So your answer should be, my dear, isothermal. Isothermal में होता है ऐसा. Okay, that you have to keep in mind, my dear. Okay, now here I will go for available energy and unavailable energy. My dear, available energy, unavailable energy. Guys, don't comment. That is what 20 PME Sagar Dharmik. Don't comment. I will take your question in the next session. जब session होगा question session तब लेंगे. Don't worry. Just see and watch. बस ध्यान से बैठ के देखो what I am explaining. Okay. You just pose this question when I will bring the model question paper. At that time, we'll definitely took it. And available energy. Okay. So available energy is what, my dear? It is a maximum useful work. It is what? Maximum useful work which can be obtained? Which can be obtained till what, my dear? Till the system, or in a process, I can say in a process which in which system attains what, my dear? System attains dead state. System attains dead state. And you know dead state is what? Atmospheric condition. Dead state means what? There is no exchange of energy. Right? I hope you got it. So my dear, I want to tell you, K is supposed to be first condition when thermal energy or we can say thermal energy at single temperature. जब single temperature पे होगा, then what should be the availability of it, right? Yes or no? So my dear, availability is equal to what? Q into 1 minus T naught upon T1. T naught is what? Surrounding temperature. This will be available energy for a thermal energy which is at single temperature, right? Matlab what? Maximum useful work available in that energy will be what? This one. Okay. Indirectly what? This is what? Indirectly it is what? It is nothing but what? This is nothing but what? Efficiency of reversible cycle multiplied by the heat supplied. Right? I hope you got it. And second, Second is what, my dear? Thermal energy with given mass of solid or liquid. Thermal energy with a given mass of solid or liquid. इनमें क्या होगी? That I have to calculate. Okay. So my dear, it should be what? That is, it is equal to phi. Directly function है. You know that phi function, and that will be equal to u1 minus t naught s1. Right? Right now, yes or no? Phi 2 will be equal to u2 minus t naught s2. Right? Yes or no? And my dear, well, yes, and then will be del phi will be what, my dear? It should be none other than u1 minus u2 plus t naught into s1 minus s2. This s1 minus s2 is nothing but what? Entropy. Remember, huh? When it is non-flow gases, when it is this is odd. This is all about what? Available energy. And this phi is known as what? Available energy function. It is what? Available energy function, my dear. AEF. Third one will be what, my dear? Non-flow gases. If non-flow gases are given, then what should be the available energy at that time? So your option will be, my dear, phi will be is equal to u minus t naught s plus p naught v. Okay, it is a function. Then what should be the del phi? Del phi will be u1 minus u2 minus t naught into s1 minus s2 plus p naught into v2 minus v1. Remember one thing here, I want to tell you something. It is what? It is your W max. ये दोनों अगर term लेते हैं, it is what? W max. But if you want maximum useful work, it is what? This to this term is what, my dear? W max useful. Okay. So when the question asks what is the formula for or what is expression for maximum useful work, then you have to mention these three terms. But when they ask what is formula for maximum work, your answer should be this one. Okay. I hope you got it. Okay, dear. Here we go for next. Ram Ram. Vaibhav Rajput ji. Ram Ram. Here we go for next. Right. Now, if it is supposed to be flowing fluid, we have next, that is what? Fourth one. We have supposed to be flowing fluid is there. Then how we can calculate its available energy? So my dear, we can calculate it by the help of its availability function, that is phi. Phi will be equal to h minus t naught into s. Okay, that is what? That is S means entropy. Okay, and one thing here I'll go for. So this is all about what? Availability. This is all about what? Availability. Remember one thing. Energy have always, this is the extra thing. Energy have always what, my dear? Always have two parts that we can utilize. That is what? Exergy, which is known as available energy, and there is one another part, that is energy. It is not spelling mistake. It is what? AN only. It is what? Unavailable energy. We are not able to utilize it. Okay. Here we go for next, my dear. Just keep silence and watch. Pay your attention. Don't comment. Nothing. So my dear, now we'll define what irreversibility. Irreversibility. Right. So what is irreversibility? So first of all, so irreversibility is nothing but what, my dear? It is known as what? Loss of available energy. It is also known as what? Increase in unavailable energy. Yes or no? Increase in unavailable energy. UAE, right? And it is also represented by W max minus W actual. That is how much maximum work has been produced and how much actually you get. The difference between them is nothing but what? Irreversibility. Remember. So what are the causes of it? We are going to discuss the causes. Causes of it. Yes, one by one. So first of all, friction. Another one, that is what? Viscous forces. Another one, what my dear? What else? Electric resistance. Electric resistance also creates what? Irreversibility. And what else, my dear? What else we have? That is none other than inelastic collision. Inelastic collision. Okay. And one more thing, heat transfer. मैंने बताया था इसका भी पहले. Heat transfer through finite temperature difference. It is also a reversible process. And what else remains, my dear? It is nothing but free expansion. What about throttling? Mixing of fluids. If you mix the fluid, mixing of fluids is also what, my dear? But supposed to be the initial properties are same and final properties are same. We can say the mixing of fluids, what, my dear? It is not irreversible. It is reversible one. Okay. So these are the causes. And there is a one scientist. एक scientist थे जिनका नाम था what is the name of them? Is none other than Gauvistodola. If you want to calculate irreversibility, you can calculate it by the help of what I is equal to T naught into delta S. That is what change in entropy. It is what Gauvistodola equation. Okay. It is Gauvistodola equation. Right. Now I'll start about pure substance. My dear, you know that. You know the enthalpy of. Now we are starting pure substance. Pure substance. Remember one thing. That I'll just write bullet point. That is what at critical point. I will talk about critical point. Critical point पे क्या होता है? Critical point पे you are not able to define, or you can say critical point पे what? Latent heat is equal to 0. Latent heat is equal to 0. And one more thing, you cannot define what? Dryness fraction at critical point. Right? Above critical point, liquid directly flashes into vapor. Right now? Yes or no, my dear friends? I hope you got it. That is critical point. And you know, now we are going to deal with what? Enthalpies. And remember one thing, ये formula you know that this is nothing but HF plus X into Hg minus HF. This term is also known as what, my dear? Like this. You know that. The only thing you have to remember, that is 1 by rho is equal to, if you want to find out density, then the formula for density will be 1 by rho F plus X into 1 by rho G minus 1 upon rho F. This will be the formula for density. Okay. So this is clear. And remember one thing, that is triple point of water. Triple point of water is what, my dear? Is appear point in only in PT diagram only. In PT diagram. In PT plot. बाकी सब में line दिखता है. In remaining diagrams, it becomes line. Okay. Here we go, my dear. Now I'll come to. Yes. Okay. Here we go. Now we'll come to, my dear, compressibility factor. Compressibility factor. Okay. See, it is denoted by Z, and it is none other than VA by VI. Ideal gases ka volume. It denotes what? It denotes what, my dear? It denotes what? It denotes or it indicates what? The volume occupied by the real gases per unit of what? Ideal gas. Ideal gases को कितना volume रहता है, दोनों के comparison में बताता है, right? So if my dear, Z का value, it may be less than 1, it may be greater than 1, right? दोनों possible है. But when Z value become 1, it is that real gases will get changed into ideal gas. Get changed into ideal gas. But remember, when Z is less than 1, it means what, my dear? It means what? Z is less than 1. It means VA is less than from VI. That means, my dear, attraction dominates. That means if the volume of the actual gas, that is real gas, is quite what? Less as compared to ideal gas, that means the force of attraction between the molecules will be very high. That it indicates. If Z, my dear, it is greater than 1, it means what? VA is greater than from VI. It means what? Repulsion dominates. Repulsion क्या होगा बच्चे? It is very high. It is very high. Remember. And there is a one term, that is what, my dear? PR, that is reduced pressure and reduced temperature. It is nothing but a ratio of pressure to the critical pressure, PCR. And similarly, TR is also what? Nothing but ratio of temperature to the temperature at critical point. And these are dimensionless terms. These are PR means what? Reduced pressure. PR means reduced temperature. And these are dimensionless terms. I want to tell you that sometimes in the examination, the examiner put a question like this: dimensionless. Which of the following is a dimensionless? And they will mention reduced pressure. बच्चे को लगता है उसका unit है. They don't have unit. Okay. I hope you got it. Yes or no? Okay. Now, my dear, you can see the van der Waals equation. Van der Waals equation, and that is what, my dear? P plus N square A. N is what? Number of moles, don't worry. V square. V minus B. Sorry, NB. I'm very sorry. It is what? NB is equal to what, bacha? N into R into T. Right? It is what? Van der Waals equation. But if you are taking 4 and 1 mole, then it become, my dear, P plus A by V square is equal to V minus B is equal to, my dear, what? RT. I hope you got it. And this will be nothing but required equation for van der Waals. It is a van der Waals equation. Okay, my dear, what should be the unit of A? It has been asked in the GATE 2016, I think. And iska jo unit hoga, it is what, my dear? M5 kg per second square. Okay, I hope you got it. Yes or no? I hope you got it. Here we go for next. Now, my dear, now we are going to deal with thermodynamic relation. What, my dear? Thermodynamic relation. So first of all, I will go for Maxwell. Relation. Right? And it should be, my dear, you know that is, we have this first one, del P by del S at constant volume is equal to, my dear, del minus del T by del V at constant entropy. This is first one. Second one, my dear, del V by del T at constant pressure is equal to minus del S by del P at constant temperature. Right? And we have del T by del P. Very sorry. We have del T by del P at constant what, my dear? Entropy is equal to what? ये किसके बराबर होता है? That is del V by del S at constant temperature. We have del P by del T at constant volume is equal to what, my dear? Del S by del V at constant temperature. Right? I hope you got it. Here we go for next. These are what, my dear? Maxwell relations. These are Maxwell relation. And my dear, you know that TDS partial differential equation, TDS जो मैंने बोला था ना, TDS relation से आएगा, that is this TDS partial differential equation. We have two equation is what, my dear? I'll write first one is what, my dear? TDS is equal to CV dt plus what T into in bracket del P by del T at constant volume into dV. Second, we have TDS is equal to Cp dt plus, my dear, what T, sorry, not minus, will be what minus what del P आएगा, what it should be, बच्चा del P आ गया. Now we have del V by del T at constant pressure, it should be dP. These are two partial differential equation of TDS, right? That you have to keep in mind. And remember one thing that I want to tell you, कि बच्चा, for real gases, you know, Mayer's equation we have derived, that is what Cp by Cp minus Cv is equal to R. It is for ideal gas. It is for ideal gas, right? But supposed to be, it is what? It is also known as what? Mayer's equation. It is also known as what, my dear? Mayer's equation. Supposed to be. If I write like this, that is what, my dear? Kt, that is, sorry, for a real gas. For real gas, what it should be? It is none other than, my dear, Cp minus Cv is equal to T velocity beta square upon Kt. Right? Where Kt is what? Isothermal compressibility. And Kt is what? Isothermal compressibility, which is equal to minus 1 by V bracket में del V by del P at constant temperature, right? And it is what? Isothermal compressibility. I hope you got it. Okay, my dear, this is what? Now we have Joule sumption coefficient, mu. Mu is equal to what, my dear? Del T by del P at constant H at constant enthalpy, and its magnitude is what, my dear? Magnitude में क्या आता है? 1 by Cp bracket में T into del V by del T at constant pressure minus what, my dear? Volume. Yes or no? I hope you got it. This equation I have to write very carefully right now. So guys, this is all about the what? Thermodynamics. And one more equation left, and that is what? Very important equation. That is Clausius-Clapeyron equation. Is very important equation. Clausius-Clapeyron equation, that is none other than what, my dear? dP by dt is equal to latent heat divided by what, dear? Tsat square in bracket Vg minus Vf. But you know that Vg is very less, Vg is very high as compared to Vf. So I can write dP by dt is equal to what, my dear? I can write what? I'll write Tsat को replace करेंगे. I'll write latent heat divided by Tsat. It is not square, I'm very sorry. अब आएगा square. And that is what? Vg only, right? So here, if I write like this, dP by dt, I'll find the value of what? Tsat. Sorry, Vg का value, V का value निकाल लेंगे, that is PV is equal to MRT equation से. So it should be what? Latent heat divided by what, my dear? T square into R multiplied by P over here, right? Yes or no? And this will be the required equation, that is what? Clausius-Clapeyron. So my dear, in this way, we have already revised what? Thermodynamics. The complete thermo is over now. The complete thermodynamics has been over. Yes. So guys, in the next class, here we stop. In the next class, we are going to continue. We are going to continue about what? The next subject को ही देखेंगे. Otherwise, we'll go for model question as paper as well. Okay. This is Clausius-Clapeyron equation, which is very helpful. Okay. And I will take your questions tomorrow. Okay. Because right now I have class. एक और class है मेरी. I have to go on that class, right? ठीक है. So guys, we are going to stop over here. Yes, you can. Now you can. If you have any queries regarding what should be done, accept your questions. Don't ask questions, because if I go for questions, my dear, it will be more than 5:15, and definitely I have class. I will miss my class. Right, so I don't want to miss my class, so that's why definitely I am available for 5 minutes. You can ask me. Yes, any kind of doubts you have? Rakil Gunda ji, had you got it? definitely. We are planning key major subjects we can go. Like thermal, it's very easy, and you know, thermodynamics covers many subjects. Like based on thermodynamics, you know why I have started thermodynamics? Because if thermodynamics is clear, if my dear your TD is clear, it's very helpful for to get RAC. It is very helpful for what? Power plant. It is very helpful to get IC engine, right? And it is also helpful. There is heat transfer. 1, 2, 3, 4, 5 subjects, and sometimes FM as well. Yes, we'll try my best so that we'll complete all the subjects. Where is next class? That is paid one. Don't worry. That is paid one. Ayush. Paid batch. That is Testbook Select. And I repeat once again, if you are interested for SSC JE, you can enroll yourself. The application link has been given in the description. Once again, I repeat, there is you can participate in Gate Reward Quiz. You will have a chance to win the prizes. Very good prizes are there. And my dear, you can explore the what? Testbook Pass, which is available in website as well as in the app. You can buy it just for rupees 299, and you are getting one pass for multiple examination, including what? Teaching, banking, defense, engineering, right? It also includes what? SSC, CGL, and it have UPSC as well. PCS services also there, right? State services, each and everything is included. So you can explore the content of this one in website as well as in the app, my dear. Okay. So we are going to continue in the next class. Okay. So we'll see you over there. So thank you so much. Yes, anybody have any questions? Please let me know. Any kind of queries? कि सर इसमें ऐसा कुछ होगा क्या, समथिंग ऐसा कुछ क्वेरीज होगा, देन प्लीज लेट मी नो. एंड आई होप ये जो नोट्स थे, दैट इज वट एवर द आई हैव रिटन, इन दिस वे आई रिवाइज. इफ आई हैव टू रिवाइज, यू हैव सीन आप में, बिकॉज why I have taken that this much time, because my dear, I have to write, I have to explain each and everything, so that's why I have taken 2 hours. My dear, when I have written in my book, what I have to just turn the pages like this. Pages turn karte chalna and you'll get revised each and everything. Right? So guys, can we stop over here? We'll see you in the next class. Okay. So thank you so much guys. We'll see you in the next class. So take care. Bye bye. Shabakar. And thank you so much for listening me. And jaane se pehle do hit like, share and subscribe the channel. Okay. So that you will get latest notification from us which and when the class has been scheduled. Right? वो आपको मिल जाएगा. So thank you so much for your presence. We'll see you in the next class. And जाने से पहले that please stay at home. Please stay at home and please be safe from what? COVID-19. घर पे रहिए, सुरक्षित रहिए. So जय हिंद, जय भारत.